Hello, I'm back, your resident engineer Jewel Ryan Nicole Viriosa. So for today, I prepared something about machine design, especially about stresses. So here I have different formulas for different stresses. So I have detailed formulas, their components, what do you need, most especially when solving problems involving stresses. I also have their sample problems, of course, and from time to time, I will be providing you tips on how to solve machine design problems, most especially for today, stresses. So let's start. So number one, first of all, we have actually the most common type of stress, that is tensile stress. So here we will be talking about the formulas of tensile stresses. So we have, since stress in general, the formula for stress is force over area. But since we are talking about tensile stress, we have the tensile force over area. And then our area differs most especially when we are talking about, for example, solid circular cross section or circular cross section. We have the area as pi d squared over 4, or others are using pi r squared. And then for hollow circular section, for hollow types, we have, of course, the internal diameter and the outside diameter. So our formula is here. We have here, I am highlighting it, this, yan, the dO squared minus di squared. So that's what we have for hollow circular section. And then for rectangular circular section, of course, our area is equal to base times height. So yan, we have base times height. Then again, next, for compressive stresses or compressive stress, this is denoted by SC. Again, you can use any other letters as long as you know that it is compressive stress. So, para hindi tayo malito, we use C as compressive stress and then we use T for tensile stress. So, next, the formula for compressive stress is another simple formula for stress, which is force over area. But then we have here the compressive force. So for the area, we also have, for solid circular cross section, we have the same pi d squared over 4. And then for circular cross section, we have pi over 4 dO squared minus di squared. Again, we have here dO squared because of the outside diameter, and then we have here di squared because of the inside diameter. And then another one for rectangular cross section, we have base and height. This is due to the reason that for both compressive and tensile stress, we are talking about the area which is perpendicular to the line of force. So I hope that's clear with you. So let's proceed to the next, which is shearing stress. So after that, after having tensile stress and then compressive stress, we now proceed to shearing stress. In here, we have formula again, which is specifically shearing due to punching of holes. So if you encounter problems mentioning punching of holes, that refers to shearing, and again, the formula is force over area. But area differs if it is for punching a hole. So that is circular, which is the area is pi dt. Yeah, we have it here, the pi dt. And then for square hole, we have the 4st, wherein S is the side of the square, D is diameter And then T is plate thickness or simply thickness. So in tensile and compressive stress, we are talking about perpendicular to the line of force. In shearing, we have here the shearing area is always parallel to the line of force. Next, we have bearing stress. So our notation for this is SB, wherein B for bearing stress. But then again, in different books or in other books, they use other notation. So it is up to you. The most important part is you know that we are talking about bearing stress. So the formula for bearing stress is force over area again, wherein the area is equal to D times L. What is D? D is diameter and then L is length. So we have here factor of safety. As engineers, we always consider safety. And in general naman, we always think of our safety. And then that is why we have also in theoretically and then in actual, we always consider factor of safety. Safety is very important, especially nowadays. So we have based on ultimate strength. So that is factor of safety is equal to ultimate stress over allowable stress. And then based on yield strength, it is equal to yield stress over allowable stress. So what I can suggest here is to read questions regarding if you are encountering problems regarding factor of safety or ultimate strength and yield strength. There are times that ultimate strength and yield strength are both given, but the question is only referring to yield strength. So it is a must to read the questions and always check if the you're answering the right question. So that's my tip. So we have another shear stress here, a kind of shear stress, which is torsional shear stress. The formula for torsional shear stress is Tc over J, wherein T is torque, C is distance from neutral axis to the farthest fiber. For circular cross-section, this is R or the radius. So again, there are times na radius ang given or diameter for specific purposes. So you must know kung ang dapat niyong gamitin is diameter or radius. So always check the label. And then for a solid shaft, J or the polar moment of inertia is pi d raised to the fourth over 32. So upon substituting it to our formula for torsional shear stress, so here's our J and then here's our general formula. Upon substituting it, our torsional shear stress for solid shaft is equal to 16T over pi d cube. You may memorize the 16T over pi d cube. This is one of the most popular formula in machine design, and this is the most helpful one. So here's what I'm talking about earlier. We use here bending stress SF. So we already use SB in bearing stress. So it is up to you if you use SB in bending stress, but then you know that B refers to bending stress. And then if you want the SF for, if you want the SB, yeah, right. If you want the SB for bending stress, it's okay. If you want to be the SF for the bearing stress, it's okay. As long as you know that your notation belongs to bending stress and belongs to bearing stress. So, it's okay. And for the formula for our bending stress SF is equal to MC over I, wherein M is moment and then C is distance from neutral axis to the farthest fiber, and then I is moment of inertia about the neutral axis. I suggest also to memorize the moment of inertia because there are a lot of derived formulas of moment of inertia for regular for regular cross section, for example, for rectangle, for circle, like that. So I suggest only. And then if you want naman, you can solve for it. But I suggest you memorize. Or you I think it is a good idea also to solve for moment of inertia. In that way, you will be more skilled, or you will be having more practice in solving inertia. So, practice your statics skills. And then, section modulus Z. And then, so we have here I over C is equal to M over SF. Ma'am, paano po nangyari yun? Because we just transpose I to the other side, and then SF becomes our denominator. So we just only interchange just in case the given is I over C. So one tip also is to learn how to manipulate the formulas or the given. And also, this is a personal experience. You have to be strong. Kailangan maging matapang ka at magtiwala ka sa inaral mo. Kasi, hindi ka naman siguro nagpagod for no reason. Nag-aral ka, kaya magiging worth it ang pinag-aralan. Okay? Nagpuyat ka, so may exam ka kinabukasan. Reward mo na sa sarili mo yung mag-perform ng maayos sa exam. Pero ako, personally, hindi ako nagpupuyat before exam. Nag-aaral ako a week before exam para masarap ang tulog ko bago mag-exam. My friends know that. Masipag ako mag-aral. They say matalino daw ako. Sasabihin ko lang lagi is masipag ako mag-aral. Masipag ako. At kailangan maging masipag din kayo. I'm not sharing this to brag, I'm just sharing my ethic, how I am committed to the things na ginagawa ko. So, okay, back to work. Strain and elongation. So, strain is equal to elongation due to applied load over original length. And then stress, again and again, stress is force over area. And then modulus of elasticity. I know you heard this having values like 12 times 10 to the 6, 30 times 10 to the 6, like that. But the original formula for modulus of elasticity is stress over strain. Meaning if stress is force over area and then strain is Y or elongation due to applied load over original length, our modulus of elasticity is equal to FL over AY. Or in short, our elongation is equal to FL over AE. As I pronounce this as flay. Flay. FL over AE. Flay. Iba, fla eh. Oh, it's up to you. Basta matandaan nyo. And then we have here the Poissons ratio. So, Poissons ratio is the ratio of the lateral unit of deformation to actual unit deformation. So, the formula is equal to E, which is the modulus of elasticity, over 2G, which is G is the shear modulus of elasticity. And other terms for this is modulus of rigidity or shear modulus of elasticity minus 1. So don't others are other people or other students mistake how do I say this? They solve this as E minus 1 over 2G. So that is wrong. You have to divide first E, the modulus of elasticity, over 2 times the shear modulus of elasticity before you minus 1. So you have to be observant with the formula. Baka kasi mali yung sulat nyo. And then, here we have sample problems. One tip also, again, my favorite tip in problem solving, of course, aside from listing the given first and then knowing what is required, you have to, what I mean is, check the units. What is required? For example, here the problem requires my answer to be in kilonewton, and then the given for steel is the modulus of elasticity for steel is 30 times 10 to the 6 psi. So I have to convert this to kilopascal because what I am achieving is kilonewton. So force, that is the question. And then length, we have here 800 mm. And then for kilopascal is kilonewton per meter squared, right? So I convert 800 mm to meters already. And then for the area, we are talking about rod. So this is a circular cross section. That's why our area is pi d squared over 4. 30 mm, that is the diameter. And then I converted it also into meters, so that is 0.03. And then E is equal to 206,785,714 kilopascal. And then the elongation, that is 1.5 millimeters or 0.0015 or 15, how do you read this? So 15 10,000s. It's hard to read decimals, right? So we read this at 0.0015. And upon solving this, typing it in your calculator, be careful in typing in your calculator. So we have 274 kilonewton. And then next, for a given material, the modulus of elasticity is 100 giganewton per meter squared in tension and 40 giganewton per meter squared in shear. Find the Poissons ratio. So here, you don't need to convert giganewton per meter squared to any unit. Since we are talking about ratio, units will be cancelled lang. So for elasticity in tension, that is modulus of elasticity. And then in shear, that is shear modulus of elasticity, which is the G. So substituting it in our formula, again, you have to perform E over 2G first before minusing it to 1. So E over 2G is 1.25 minus 1, which is, the answer is 0.25. Our Poissons ratio is 0.25. So, I hope you learned something from what I have discussed discuss this day. So again, if you wish to have a copy of this PowerPoint presentation, which is merely about summary of formulas for stresses and tips, sample problems. And if you also have some questions regarding the topic, kindly email me at my personal email, ryannicole05@gmail.com. So thank you very much. See you on my next videos. Thank you. Keep safe.